Okay, thank you for introduction. Hello, I'm Hayeon Choi and a doctoral student in the Nutrition and Hospitality Management. Before starting, I'll share my practice data because it will take few seconds to download, so I will share it in chat. Okay, I uploaded 4 files in chat, so if you can, please download it. I'll start now. Today we're gonna be dealing with 2 non-parametric tests, which are Wilcoxon signed rank test and Mann-Whitney U-test. As mentioned by Sung last week, if we have 2 samples and if measurement types are rank or ordinary, then we can use Mann-Whitney U-test or Wilcoxon signed rank test. Then what is the difference between 2 tests? It's depending on samples. If you have 2 independent samples, for example, you've got males versus females on some measure, then that would be definitely be 2 independent samples. Then we will use the Mann-Whitney U-test. If samples are batched together or pairs, then we can use the Wilcoxon signed rank test. An example of matched pair scenario might be where you've sampled the same people before and after some kind of intervention. First, let's see a Wilcoxon signed rank test in detail. As a concept, Wilcoxon signed rank test is non-parametric statistical procedures for comparing 2 samples that are paired or related. And this test has 1 written subject variable. So this test is used when same group is tested twice, such as pre and post test. The parametric equivalent to Wilcoxon signed rank test is the dependent t-test. And let's see a difference between Wilcoxon signed rank test and dependent t-test. Dependent t-test tests the difference of mean between 1 dependent group, while Wilcoxon signed rank test identifies the difference of ranks between 1 dependent group. And let's see an example together here. There are scores of pre-self-confidence and post-self-confidence. First, you should calculate a difference between pre-scores and post-scores. So for ID number 1, the pre-score was 31 and post-score also 31. So difference is 0. And then what we are going to do is rank the absolute value of these differences. The third column is absolute value, and we need to rank this absolute value. The ranking starts at 1 from the lowest absolute difference. So ID number 9 received ranking 1. For the Wilcoxon signed rank test, we can ignore cases where the difference is 0. You may notice that the tied rank was given to ID number 6 and 8, which have same absolute differences. In this case, we can give the tied ranks, the average rank is calculated. Let's see the hypothesis testing process together. Research question toward this data is there any difference between pre and post self-confidence scores after a month of walking treatment? In this data, dependent variable is gonna be self-confidence score, and independent variable is gonna be measurement time point, which are pre-treatment and post-treatment. So we can use a Wilcoxon signed rank test. As mentioned in the previous slide, a research hypothesis is gonna be there is a difference between pre and post self-confidence score, and null hypothesis is there is no difference between pre and post self-confidence score. And 0.05 of significance level is used. Next, we should compute the test statistic. There are 2 methods depending on the same sample size. It's not that difficult, especially with a small sample. I'll talk about how to calculate the test statistic with small samples in just a few seconds with the data example. However, if sample size is more than 20, it's kind of hard to calculate. So SPSS result will show you the Z scores when you have a large samples. If sample size is more than 20, we will approximate it to a normal distribution. Because the Wilcoxon sign rank test is non-parametric test, it does not need multivariate normality in data. Before computing the test statistic, we should apply the sign back to each rank. If the original difference is negative, then the rank is gonna be negative. And if the difference is positive, then the rank stays positive. Let's take a look at how to calculate the test statistic. Because the size of sample is small, we just need to add all positive rank and negative rank separately. The first one is the sum of positive ranks, and the next ones are the sum of all the negative ranks. Here, what we are going to use is the smaller one, the sum of the negative ranks, which is 7.5. With this value, we are going to compare it to a particular critical value that will tell us where we can reject the null hypothesis or not. So let's find out how to do that. Let's take a look at critical value table here. The significance level we set was 0.05 and the sample size was 10. The numbers supplied to us is here 8. If a test statistic is equal to or below this critical value, then we can reject the null hypothesis. We had a test statistic value that was 7.5. So 7.5 is below 8, meaning that we can reject the null hypothesis. As a conclusion, we have sufficient evidence to show that pre and post self-confidence scores are different after a month of walking. I'll show you how to conduct through the SPSS. First, with the data, you can click Analyze and Non-parametric test and legacy dialogues and 2 related samples. And then put pre and post scores in variable 1 and variable 2 and check Wilcoxon and then click OK. Then you will get a result like this. If you have a small sample, then you can use this score, the smaller one, which are negative ranks, and comparing those value with the critical values in the table. If you have larger sample, then you can use the Z score here. And I will show you this process in the SPSS data. Here's I have same data in the presentation slide. First, you should click Analyze and click Non-parametric test and legacy dialogues and 2 related samples. Then you can put pre-data, post-data in variable 1 and 2 and check if the Wilcoxon was checked and click OK. And then you will get a result like this. Because we only have 12 samples, so we will use the result in the ranks table, and we will choose the smaller value in the negative ranks, and we will compare this value with the critical value in the table. Because 7.5 is below than 8, so we can reject the null hypothesis. For reporting the result, the Wilcoxon signed rank test indicated that the pre and post self-confidence scores were significantly different. In addition, the sum of the positive difference ranks was larger than the sum of the negative difference ranks, showing a positive effect from the program. Therefore, our analysis provides evidence that the working program is providing positive benefits toward the improvement of self-confidence. And do you have any questions about Wilcoxon sign rank test? If not, I will keep going to Mann-Whitney U-test. As a concept, Mann-Whitney U-test is non-parametric statistical procedures for comparing two samples that are independent or not related. So if we have two distinct samples and have one between subject variable, then we can use a Mann-Whitney U-test parametric. The most common independent sample is gender, like comparing the difference between males and females. The parametric equivalent to Mann-Whitney U-test is the independent t-test. Independent t-test tests the difference of mean between two independent groups, while Mann-Whitney U-test tests the difference of rank from two independent groups. In this test, we are still going to be ranking all of the data, but no longer we are interested in the differences. We are just going to rank the scores from smallest to the largest. So the smallest score is 10. So this gets rank of 1. The next one goes up to 12, and that's rank 2. Let's look at the hypothesis testing. Research question is male's depression score higher than female's depression score? And dependent variable is depression score, and independent variable is gender, which is the most common independent variable. The null hypothesis here is that male's depression score is not higher than female's depression score. So we'll identify that we can reject this null hypothesis or not through the Mann-Whitney U-test. And we set the significance level at 0.05. Next, let's compute the test statistic. The formula is here and we'll compute it together in the next slide. If there are large samples, then we will approximate it to a normal distribution, and we will also get this value through the SPSS. First, let's compute the test statistic of male. The sample size was 7 each for male and female, so we can put N1 as 7, N2 as 7, and sum of all the male ranks is 70. So if you put these values in the formula, the male's test statistic is 7. And then for the female's test statistic, the sample size was 7 each again, and the sum of all female ranks is 35. Thus, by putting these values in the formula, the female's test statistic is 42. As we did in the Wilcoxon signed rank test, the smaller one will be used, which is the male test statistic value 7. Next step is identifying the critical value. The significance level we said was 0.05, and sample size for each variable was 7 each. The numbers applied to us is here 8. We have a test statistic that was 7, so 7 is below 8, meaning that we can reject the null hypothesis. As a conclusion, we have sufficient evidence to show that male's depression level is higher than female's depression level. As the process in SPSS, with the data, click Analyze and Non-parametric test and legacy dialogues, and you need to choose 2 independent samples because you have 2 independent samples such as male and female. And then put depression score, which is dependent variable in the test variable list, and then put gender, which is independent variable in the grouping variable, and click define groups, and put group 1 as 1 and group 2 as 2. and click continue and click OK. Then you will get a result like this. Because we have small samples, so we can use the value in the first table, and we'll use the smaller value in method 2. And using the formula, the SPSS will give you a result of Mann-Whitney U-test. So the score is 7. And comparing this value with critical value in the table. But if you have large samples, then you can use the Z scores in the SPSS here. And I will show you the same process with the SPSS. First, we have 14 samples here, and click non-parametric test and legacy dialogues, and click 2 independent samples. And then put dependent variable in test variable list, and put independent variable in grouping variable, and define groups 1 and 2. Then click continue and check if Mann-Whitney U-test is checked, and click OK. And then you will get a result like this. So Mann-Whitney U-test score is 7. So we'll compare this value with the critical value in the table. Because 7 is below 8, so we can reject null hypothesis. So when we report the result, depression test was used to provide gender. Using the ranked depression scores, the result indicated a significant difference between male and female. The sum of ranks for male was larger than the sum of ranks for female. Therefore, we can state that the data supports that male's depression level is higher than female's depression level. And that's all for my presentation. And I uploaded 2 practice data in chat, so please open it, and for 5 minutes, please conduct the Mann-Whitney U-test and Wilcoxon signed rank test.
So the data, the names are practice, right?
Pardon, I didn't hear you.
The name of the
Wilcoxon practice data and Mann-Whitney U-test practice data.
Okay.
Okay, let's do it together. Do you think if the result is significant or not? Or we can do it together. First, for the first data, Wilcoxon practice data, to do this, we need to check the variables because it's the same dependent variable, dependent samples, and we have two scores of pre-treatment score and post-treatment score. So we can use Wilcoxon rank test and click analyze and non-parametric test and click release dialogues and two related samples because this is the pre and post data, and put treatment 1 as variable 1 and treatment 2 as variable 2 and check if Wilcoxon is checked and click OK. Then the result show like this. Negative ranks is 10 and positive ranks is 26. And then let's see the research question together. Research question was researchers compares two different to help obese female lose weight. The researchers test each individual in two different treatment conditions, and is there any difference between treatment 1 and treatment 2? And we set the confidence level at 0.5 and determine if differences exist between the two treatments. And we conduct the Wilcoxon sign rank test here. And as I mentioned before, we will use the smaller value here, which is 10, and we will compare this value in critical value tables. We had a total of 8 samples, so the sample size 8, and we set significance level at 0.5, so critical value is 3. But our result is bigger than 3, so we cannot reject null hypothesis. So the result is the Wilcoxon side rank test indicated that the treatment 1 and 2 were not significantly different. And then let's go to the second one, Mann-Whitney U-test practices. And there are two independent variables, which is group 1 and group 2. And the research question for this data was, a study was conducted to see if an involvement in a hobby tended to reduce the need for doctor visit, and report your findings as significance level of 0.5 and determine if there is effect of hobby on the number of doctor visits. And let's do the SPSS together. First, click non-parametric test and legacy dialogues. And in this data, you need to choose two independent samples. And put hobby group in the grouping variable and set 2, 1 and 2, and put dependent variable in test variable list box and check if Mann-Whitney U-test is checked. And click OK. And the result is show like this. And our Mann-Whitney U-test value is 3.5. And compare this value with critical value in the table. And we had sample size of 6 each, so 6, 6, and our critical value is 5. So compare this value with our value, and our value is smaller than 5, so we can reject null hypothesis. So as a result, the result indicated that a significant difference between two groups, the sum of ranks for non-hobby group was larger than the sum of ranks for hobby. Therefore, we can state that no Habit group visits doctor more than Habit group. Okay, that's all for my presentation. Do you have any questions about Mann-Whitney U-test or the Wilcoxon sign rank test?